Single phase bridge type cycloconverter with RL load. Now I want to step down my 50 Hz frequency to 25 Hz. 50 Hz frequency is taking 2 pi radians to complete one cycle. Then 25 Hz will take 4 pi as frequency is inversely proportional to the time period. Then in which 0 to 2 pi I need to get positive half cycle of the response, and 2 pi to 4 pi I need to get negative response of the output. Let us see. We have converter 1 and converter 2. Converter 1 consists of P1, P2, P3, P4. Converter 2 consists of N1, N2, N3, N4. When Vs is positive, Vs is negative. When Vs is positive, then I can operate P1, P2 since they are in forward biased. Similarly, N1, N2. When Vs is negative, I can operate P3, P4 in converter 1, N3, N4 in converter 2 as they are forward biased. Then when I operate P1, P2, P3, P4, I'll get the output as, when I operate N1, N2, N3, N4, I'll get the response as negative. Since I'm having RL load where L is the inductor which does not allow the flow of current to change instantaneously, even the voltage becomes 0 at pi, the current is not going to become 0 at pi, it will extend to beta. This beta is greater than pi. Pi plus alpha, if it is equals to beta, I'll be getting continuous conduction mode. If pi plus alpha is greater than beta, then I'll be getting discontinuous conduction mode of operation. Now let us see one by one. Now, discontinuous conduction mode of operation is possible when pi plus alpha is greater than beta. In positive half cycle, I can operate P1, P2, N1, N2, but to get a positive response, I need to operate P1, P2, negative response, I need to operate N1 and N2. From 0 to pi, at alpha, P1, P2 is triggered, then the current path I flows through X to P1 are a load to P2 to Y. Between pi and 2 pi, at pi plus alpha, I am turning on P3, P4, since it is a negative half cycle where I can operate to get positive P3, P4 or N3, N4 for negative. Current flows Y to P3 are load to P4 to X. Between 2 pi and 3 pi, at 2 pi plus alpha, this is a positive half cycle. In positive half cycle, I can operate P1, P2, N1, N2. But I need to get the negative, so N1, N2 I'm operating. N1, N2 is turned on, then the current flows X to N1 or a load N2 to Y. Between 3 pi and 4 pi, at 3 pi plus alpha, I'm turning on N3, N4, then the current flows from Y to N3 to the RL load to N4 to X. Now if you observe, here the current direction is from P to L, P to L. Here the current direction reverses L to R, L to R. Now replicate this in the waveform. In positive half cycle at alpha, the input voltage appears across the load and becomes 0 at pi. Due to the inductor, the negative peak appears up to beta. Each half cycle will be having alpha and beta. The input voltage appears in the opposite direction. We'll be getting negative peak here. 2 pi plus alpha, 2 pi, again negative peak due to L. Then at an alpha, so this is P1, P2, P3, P4, N1, N2, N3, N4. This cycle repeats. Current will start here, ends at beta. Start here and ends at beta. Starts here, ends at beta. Starts here, ends at beta. This is current I. Now if you observe, the current is 0 in between beta and pi plus alpha, pi plus beta and 2 pi plus alpha, 2 pi plus beta and 3 pi plus alpha, 3 pi plus beta and 4 pi plus alpha. In between these intervals, the current is 0, or else the current is discontinuous. This is discontinuous mode of operation of the cycloconverter. Here the thyristors P1, P2, P3, P4 and N1, N2, N3, N4 all comes to rest due to natural commutation only. Now, continuous conduction mode of operation. The same sequence of P1, P2 P3, P4, N1, N2, N3, N4 we operate as we operated in discontinuous conduction mode, but the condition is beta equals to pi plus alpha. Similarly, pi plus beta equals to 2 pi plus alpha, pi plus beta equals to 3 pi plus alpha, and 3 pi plus beta equals to 4 pi plus alpha. Let us draw. Alpha starts conducting a half cycle and becomes 0 at pi and continues in negative up to beta here. This is alpha and this is beta. At beta, turning on the P3 and P4 up to 2 pi, it's continuous, then beta. At 2 pi plus alpha, I'm turning on. This is P1, P2, P3, P4, N1, N2, N3, N4. Now the current starts conducting. Discontinuous conduction of the current disappears and the current becomes continuous. This is how you get continuous conduction mode. The load current may be continuous or discontinuous depending upon the firing angle and the load power factor.